Ah, hello, hello. We are live. And if you are new to the channel, this is kind of out of character, I guess. Maybe not out of character, but man, that is a lot of reflection on these glasses. But I wish solid. Maybe I should do the background to make it a little darker. Let's do like this might be a little bit better, just for sake of not shining so brightly. You know what? No, maybe we'll do like a blue. Nah. Sorry, I'm just messing around with the background here because it's like so bright in my eyes. We could do factory. We'll add factory in there. Where are you, factory? There you are. Ooh, urban decay. Let's see. We will start off with saying welcome to the stream. And like I said earlier, this is kind of out of character. Not out of character, but this is a different type of stream. So this is actually software that I use at work. The subject of our design today is going to be this baby, 3060 Ti FE. And the main reason is right now I'm working on designing a mini ITX or micro mini ITX, whatever. The ITX, the smallest motherboard form factor. And my goal is to have this case as small as possible. And part of that, achieving that, is going to be getting a bit creative with how to mount the GPU. And in order to get creative with it, I need to have an accurate model of it. Now, right now, I've got a model, but it's like of a 3080, and I don't think it's accurate. The heights on it are a little bit off. It looks good. It's got nice fans in it, but I don't think it's actually fully accurate. So I'm going to design my own basic block, more so for just figuring out the layout in the case itself. So let's get into it without further ado. So I've got my title already. I've already saved a part file. So I've created a part file. There's options, file properties that you can go into, and you can fiddle with you know, different items like this. That's not what I wanted to do. Not that properties. Tools. There is document properties. I'm pretty sure. Where's options? There's a lot of stuff in here. And I don't even use all of the stuff. I work with this software at work, and I don't even use all of it. And I don't think everybody uses all of it. We're gonna go to tools, and I'm pretty sure it's in options. Yeah. So in here you can do your basic document settings. So if you want to have here document properties. So you can have your drafting standard. You can adjust this to ISO, DIN, JIS. I typically use ANSI, so I'm keeping it as ANSI. Annotations, you can, this is just like different items. Dimensions, you can even go in and fine tune how your dimensions are. This is stuff probably if you're a beginner, you're not really going to be interested in. But things that you will probably be interested in, you can set up your units here. So if you're doing like millimeters, gram second, inch pound second, centimeter gram second, I don't know. I don't use a lot of the time stuff, so those last ones are really pointless to me. I'm typically at work, I'm using inch pound, but for the sake of the 3060 Ti FE, I'm pretty sure these are predominantly metric parts. So a lot of these dimensions, a lot of these features are going to be metric. So it makes sense to make sure that it's in metric. So we're going to do it all in metric. Okay. So first step, here's your planes within the 3D space. You've got your origin right here. So your right plane, top plane, front plane, and you can even like adjust your views to those different planes to switch your view on this. But regardless, we are going to do a front plane, and we're going to go normal. This is to adjust the view in here. And there's another way that you can adjust the view, and I'm going to show you that later. It's a little bit easier to see once you have an actual part on there. So we're going to start on the front plane because we are going to look at this card front on, and we're going to create a sketch basically of this card. And mostly what I'm going to be using is this this feature here. I'm going to create a solid feature of this along that path, and I'm going to design. I'm going to model that, and we're going to go. So here you click, you're going to have a few different items here that you can click on. Some of these are add-ins, which you probably won't have, especially if you're doing like a more basic version, but you're going to have features, sketch, markup, evaluate, all over. Some of these, again, you're probably not going to have, but so we are going to extrude a boss slash base. So you have to either extrude or revolve right off the bat. And you can input reference geometry. So if you want to make a little bit of a weird reference plane that's not quite aligned to the coordinates, and coordinates probably aren't going to make much sense right now. So we're going to, again, get into it here. We're going to do a boss slash base. So this is what you're going to start off with. You're going to create a sketch of a profile, and you're going to extrude. There's even a nice little animation there for you. And we're going to do it on the front plane. So you click on the plane that you want to do it on. You can even do a sketch. So you can start with a sketch, or you can click this and it'll automatically put you into a sketch. So right now we're in a sketch. Right here you can see exit sketch, X here. You're going to notice that a lot of the other functionality is going to kind of disappear. Right now you can do a sweep as well. So we are going to do the front plane. And since we're going to be doing this, which looks very much like a rectangle, we're going to start with a rectangle. All right, and here is your rectangle. You can start with a corner rectangle. But since I want this rectangle centered on the origin, I'm going to switch this to a center rectangle and just click and drag. And close the dialog. You click off of it, and you're going to see that these are all blue. And these points are blue, which means you can move, adjust, all these things. The only constraints are that these lines are horizontal and these lines are vertical because it is a rectangle. And because you clicked on here, it's going to be stuck on the origin. So that means the centroid of the rectangle is going to be stuck on there. So it's not going to move. You can't move it off because we have that coincident. So so when you click on any line in the sketch, you're going to see relations, and you can add relations relative to other lines. So if I click this and click this, I could add perpendicular. It's not going to do anything because they're already perpendicular, because this is vertical and this is horizontal. So we are going to just do dimensions. I've already measured roughly the measurement on a 3060 Ti from this end right here to the inner side of the mounting bracket here is 242 mil. So we're going to take this, we're going to go here, and we do 242. So that makes that 242. I don't know, is this background easy to see or not? Maybe, maybe not. I'm going to do the height of it now is 98 millimeters. Now I'm just measuring, not including the PCIe slot or the PCIe. I'm just doing top of the cooler to the bottom of the cooler right now. I'll add that in later, but the that dimension there is 98 mil. So go here, 98, enters. There is our rectangle. Now, I also measured this. You've got a radius here and here. They kind of have a radius over here and not a radius where it butts up on one side, but there is kind of a radius drawn in there. So I'm going to make this radius all around. So to do those, you're going to go to the fillet function. So sketch fillet. So we've already got our dimensions, but they're going to the ends of these straight lines. If you add a fillet in there, like you could draw like a line. If you wanted to do it like a little bit more difficult, you could draw a line, click, you have a line, you touch the point again, and then it makes it a radius. Click, click, touch that line again, you make a radius. You could do something like that with our rectangle. So this already has a tangent there. You got to maybe add a tangent relation between this and this, because if you don't, look, it comes up. So you go like that, click those two, select them. You hit control to select both, and then you hit tangent. So that will define it. These are already tangent. And you can do that to add a radius. It's just a little bit easier because you draw your thing, and then you can do this, and then you just click this one, this one, this one, this one, a radius between this line and between that line. Look at 15 millimeters. I've already done this before, and the radius of these corners on your 3060 Ti Founders Edition are 15 millimeters. The way I figured that out is I'm measuring this in a very sort of janky way. So hardly I've got a ruler here, and it's a metal ruler which is relatively straight, and you've got a relatively straight edge here. And so I set it on a flat surface, straight edge to straight edge, and then I just looked at what dimension I couldn't see daylight through. And that's where the end of the radius was. So that's how I measured the radii on this. And they're all 15 mil. So, boop. So you can see these center lines, they've still extended to the point where these would intersect. So these sort of things happen automatically within it. So you can still maintain your features, your relations, all that. So another thing I measured on it as well is the thickness of this piece here, because I want to get the thickness of it just so it looks relatively the same. And the thickness of that is 5 mil. So the quickest way to get a 5 mil line in there is to go to offset entities. So I hit offset entities. So what this is going to be is whatever I select, it's going to offset a line one direction or the other, or it can do both directions. So I can also select chain. So if this isn't selected, I can select it and do one line, or if I hit select chain, it's going to do all the lines. So it's going the wrong way. I want this to go inside. So I'm going to hit reverse. So it goes inside, or you can do bidirectional, which goes either way, but I'm not going to do bidirectional. It's inside the whole chain, and we are going to do 5 mil. So that goes inside like that. You're going to see two, you've got roughly these, let's see, can you see this? So you've got an angle here on this piece, and it's roughly parallel with these angles right here, these fins. And so I measured, and I got a rough estimate of about 68 degrees. So the angle on them is going to be about 68 degrees. So I am going to go like so. We've got this angle that goes between, and smart dimension, just going to measure that, or dimension this to say this line, 68 degrees. And we are going to go ahead and do a radius here, because there is a radius, and we're going to do a radius here. So basically I'm going to, instead of, this is another way of doing radius. I could do a fillet here, but I don't want to because it's going to break some relations. So I'm putting a circle here, and what I'm going to do is I'm going to use the trim command to trim some lines. But first, I've got this as already tangent to that line. I want it tangent to this line. And we're going to take this one, and we're going to make it tangent also to this line. And since these are all the same size as this, oh shoot, no. See, I made a mistake. I don't want that coincident on that. I want this to be coincident on that. That is the coincident relation right there. This, I don't want to be tangent on that. I want this to be tangent on this because it's actually the outside. All right, this, I'm going to break that or delete that. I'm deleting these relations so it can move. If I didn't, this would be sort of just growing but touching this line and this line. So now I can move. I'm going to make it, no, not fixed. This guy is going to be on that tangent. And then this, and this are going to be equal. So if I make it equal, it's going to make this radius, this diameter, all equal. So if this radius was a diameter, this diameter was a radius, whatever, it's going to make them the same. So now these will be 30 millimeters. So if in SolidWorks, you can actually see the dimensions down here. It even shows like where you're in this bottom corner of your screen. It'll show you, yeah, it's underdefined. Anything that's blue needs to be defined further, or else it just says that, you know, if you grab it, it'll. So we will continue on with our little stream here. But yeah, as I was saying, blue is unconstrained, which is bad. You want your sketch to be fully constrained. So once you're done your sketch, everything should be black. So we will go ahead and this guy here is I'm gonna offset this right here. Another 5 mil, and I'm gonna show you the trim function. So trim function, ideally we want this here. There's also another feature down here where that line kind of stops, right? We've got this line, right? It goes all the way around, and we want it to terminate here and terminate down over here. So I'm drawing those in right now. So this line here, and you can hit, like, you can do quick things. So if I hit L, it will give you line. Also here, if you hold your, I think if you hold your, yeah, here it'll show you the hotkey for it. If there is one. L for line. But it's nice. It actually shows you little animations in 2022 on like how it actually works to get it going. So it's actually very, very user friendly for new users. And we're going to just, oh yeah, I was going to do a line here. So we've got this also this way. So this, and this. Oops, not that. I selected this, the chain. This, and this are all going to be parallel because this is all 68 degrees. And now what I'm going to do is I'm going to use the trim function. And we are going to trim this down. So we're going to trim this guy here. Trim that. We're going to zoom in. And we are going to trim this guy, this, and this. Also this line, and this line. And this line, and this line. Oh, we need to offset this. Oops, we'll offset this as well. This should be 5 mil. Not the chain. Yeah. See, it won't offset the chain. It will offset that single one, and we're going to bring that in that direction, and we are going to want to offset this also out, I believe. 5 mil. Yeah. No, not out. We'll undo that, and we'll offset that in. No, we don't want to offset it in. What am I doing here? Okay. No, we want it out. There we go. Now we're good. Okay. No. No, we don't. I have this tangent to the wrong line. That's why. Tangent to that? No, this should be actually tangent to that line. Boop. And then we offset this in. Yeah. Set that reverse in. There we go. That's better. Now we are also going to go here. We're going to trim this. So we have this nice radius. Ah, we have a disaster. Everything over constrained. Look at this disaster. So look, we've got 5 mil to find there and 5 mil to find there. It's over defined and 5 mil there. All right. So we've got these dimensions here, which are red, which is triggering us to look at them like you've created a problem, buddy. So let's delete that one. And let's delete this one. And suddenly everything is all right. So red is over constrained. So yeah, we will go ahead and trim now down here. This may also still give us a issue, but you know what? We'll deal with it. Deal with it. Doot, 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 doot. And doot, doot, doot. Beautiful. There we go. This is our rough outline of our path for our 3060 Ti Founders Edition. Now, we need to figure out this. I've already measured that. That is 85 mil. And usually what I do when I'm trying to figure this out, it also is sort of, I don't know, 85 on that. So look at that, fully constrained that way. And this one here to here is actually 82 mil. I measured it. I was like measuring it. I was designing. I was like, you know what? Maybe I'll do this so people can sort of see what's going on when we're doing like a design on this. So I'm going to, let's see. I have a suspicion that this gap is the same here as it is here. I have a suspicion. So we will see. We shall see. So I'm just going to do a quick rough measurement. This guy to there is about 50. This guy to here. It looks to be the same. I'm going to measure the stack of... There's a fin stack on either one. I've got to be careful not to compress them, though, because that will distort my measurement. I'm using a pair of calipers right now on it. It's about 51 mil. And this side here is about... Oh, it looks like it's a little... Actually, you know what? It is noticeably shorter. Interesting. Very interesting. Okay. I thought it would have been the same, but it's not. It is not. So I gotta measure this. So I will measure this in... So let's see. I'm going to use that daylight method I was talking about. I'm going to line this here. I'm going to set it at, yeah, I'm going to start at the 10 mil, and we're going to work back. I'm just laying the flat edge on there, or the straight edge on there. Bringing it back, yeah, about 45. So that is 55. 50, 65. 1, 2, 3, 4, 5, 60. Yeah, about 65. 65 mil on the bottom is what I measured. Actually, wait. I already have that defined. This is what I was measuring here to here. I measured it at 65, but actually, no, that's closer to 57. So I'm not quite measuring it well, but I'll measure it on the other side now. See what I can measure with that one. Yeah, you're looking at 60. Wait, 65 there. 65 here? No. No, come on. That looks to be actually the same. All right, so it is the same. 57.44, 57.44. Lovely. So this here, actually, a nice way. I can do it with a dimension, but a nice way to do it, where I won't have to dimension it. Where did my mouse go? There's my mouse. Is I can do a line, which is for construction. So it'll ignore that when it's trying to develop profiles. And I will do a line right here, which is also for construction. Actually, no, I need to trim that. First, let's trim that. And now I will make another line for construction between here and here, right? So I could dimension it here, but a nice, quick, easy way is I click this, and I make them equal. So now that it's equal, there we go. It doesn't look right, though. It doesn't look right. This shouldn't be equal, I don't think. I'm like looking at it now, and I'm like, is this actually how it looks? You know what? I'll see. Let's see. Let us see. Oh, this is gonna be a bit of a pain to measure. I can't use my flat surface measurement. The thing does look like it's close to 95 mil. So this from here to here looks like it's close to 95 mil. And that is also taking into account the thickness of the plate, which is, again, roughly another mil. So here we're saying what? 99. Yeah, that's probably closer to 95. It's not deadly necessary for that to be fully accurate, but it just didn't look right to me. You know, we'll take that down to like 93. Yeah, that looks like a little bit better. All right, so there's the outline of it. Beautiful. Absolutely perfect. All right, now we are going to extrude that thickness of the part itself. So we do have, there is a back plate on it. So when I'm measuring the full thickness, it's including the back plate. So we're getting about 40 mil, or actually 39 mil. And I'm getting about 35. So 35 and then 39. So yeah, so we're getting about 35. Actually, no, here's a good one. I can actually just measure down to the PCB from the edge here. And yeah, we're getting 34.75. Oh, 34.9 there. Measure over here again. Take another point. 34.5. Actually, if I'm crooked, it'll give me a bigger number. So the smallest number is actually most likely the accurate number, which is 34.5. Okay, 34.75 there. Yeah, 34.75. All right. Now we get to see the magic. Why 3060? A 3060 Ti because it's the smallest GPU I own. That's really why. And I want this case that I'm going to be putting it in. So I don't know if you were here, DevGear, for the beginning. I was talking about just why, sort of what's going on and why I'm designing this. So I'm designing this to because I'm creating a small ITX case, so a really small computer case that I'm going to be printing on my 3D printer. And since this is the smallest GPU that I own, that's why I'm doing this one, because I want to have the smallest case possible with sort of what I have on hand. So here we go. We are going to now make the magic happen. We're at 34.75, so extrude boss slash base. And we are going to extrude this guy. And you know what? I'm going to extrude this up. Usually when I do this, I usually go mid-plane because I like to have the center of this for mounting purposes. But actually, it's going to make sense to have this blind. So you have a few different things. You can go up to certain features. So we don't have any features already in there. So offset up to these are not really going to help. Up to body. Also mid-plane or blind is usually what you're going to want to use if you're starting off. So I'm going to do blind. So it's going blindly into one direction as far as I tell it to, which is 34.75 mil. Not A. 35 mil. There we go. Boom. So there's our cooler frame. Pretty cool, huh? So now on this part, we've got the one side. Actually, I'm going to go back to so this side is where the IO is, and this side is the end of it. So right up here is going to be your power connector, and down here is where your PCIe is going to be. So I could dimension and or not dimension. I could create this as a component and put it into an assembly, which I might do. So I'm going to quickly do chamfer on this. This guy is chamfered. So you can break edges on here. So this is 10 mil chamfer. It is definitely not a 10 mil chamfer. This is 5 millimeters wide. There's a chamfer on either side. As you can see on these, there's like that facet on there. That's the chamfer. And it doesn't even go the full thing. I'm going to assume it's a 45 either way, which it kind of looks like. And it's probably... looks like it's even, symmetric. And I measured the inside is 1¼ mil. So 1¼ mil from 5. So actually, you know what I can do is you can actually do the math in these boxes, right? So I know that there's 1½ mil in the middle. So we are going to do bracket 5 minus 1.25 divided by 2. And it gives you that right there. You can just add the equation in there and it'll do it for you, which I think is kind of neat. And it's also chamfered there, and it's also chamfered there. Boomity boom. Doesn't that look nice? Looks pretty accurate in my eyes. Okay, okay. And this chamfer is actually going to help us with determining the IO portion of it. Because here is going to be, there's a little spot where this actually sort of bulges. So we're going to do extrude base right here. And we are going to convert that. So convert basically, so we're, let me just go straight on here. So when I hit the convert, it basically takes all the lines from this face and it creates sketch lines in the sketch from it. So if I click on that and I hit convert, it takes this line from that curve, but looking at it straight on, and I get those items there. So on the bottom portion, this is actually going to come straight out to this surface. This one here, it's a little bit more complex. We are looking at where that one comes out. Let me just quickly shift my microphone. And I'm going to sort of scooch down here and get an idea of where this, because I have to look at the flat surface. So I'm gonna scooch down. I'm gonna be like off camera here for a second while I look at it. Okay. Yeah, roughly like 1 centimeter, maybe 8 millimeters. Yeah, let's say 8 millimeters off this one. So basically we're gonna go here to here. That's not straight. So we are going to make that horizontal. Now it's straight. Oh, where are you on that point? I don't want you on that point. I want to dimension you to define you. So sometimes it'll snap to a point and it'll define something for you. But yeah. Oh no, it's not 8 there. It is actually 8 from the top of the radius. So we're going to go 8 here. 8 mil, boop. And features. Now we're going to extrude this part and this part. So we don't want to extrude it that way. We want to go that way, but we don't want to go blind. We actually want to do it up to body. So we can't go up to a surface because this is actually going to be connecting to 2 separate surfaces. We could do up to a point, but not really. So we are going to go up to the body. So these should go into the body. This is not helpful. Why do you not want to go into that body? Merge result, yes. We don't, yep. Select a solid surface body. Oh, I gotta select the body first. What are you saying? The selected direction. Oh, it's the direction. That's the body. There we go. I had to add the body in here. So we're going to select this part here. Now it's going to go up to this body that we've selected. And there. So yeah, this is where the IO is going to go. There is a radius on the one side, on the outside, and a very small one on the inside. So this here has a radius. So I'm going to add a fillet on there. Full preview. 10 mil, obviously too big. I think it might be a 5 mil radius. Oh no, we don't want to go with the radius in there. We don't want it to continue in there. Can we decrease this? Oops, no. Oh, this is doing it in very big units. So we're going to go 4 mil. Radius. I just want to there. Yeah. Yeah, that's roughly it. It again, like I said, we're not actually, you know what, I want to also add there's kind of a fillet here and here. Actually, we're not going to fillet that one then. Fillet that, and then we'll also do another fillet here. Again. Boop. Yeah, sure. Why not? There we go. This is not correct, but it's bothering me. So we'll get rid of that tangent propagation maybe. Will it still work? No. Fillets are sometimes where the battles are won and lost in Solidworks. Why am I not using Blender? Because I use Solidworks. That's why. I hope that answers your question. No, I don't use... I don't use Blender. I only use Solidworks. I've actually never used Blender in my life. So actually on this feature now, there are some screws here that I want to sort of grab because I'm kind of contemplating to save space in the case is actually to remove this plate, this mounting IO mounting plate, and just take that off and then just have this actually mounted in the case, because there's a lot of extra room that comes off the bottom of this, and I want to get rid of that so I can have it in a smaller spot. So I'm actually thinking about taking these off. Uh, so I want to use those mounting hardware parts, or mounting hardware points for the actual case itself, in the case. So I'm actually going to take a couple of screws out, and I'm going to just with these screws out get the dimensions for the hole spacing on those screws, because I'm thinking about running those screws through. I'm not sure if I'm going to. So I'm just roughly putting my caliper on here and trying to roughly see where the center to center on these holes are. And we're looking at about, what, 17 mil? Yeah. So we're going to do some holes here. Extrude cut now, so you can cut holes in here. So we're going to do a sketch. Yeah, we got our sketch. I'm going to convert this face just so I know where things are. And we've got about this hole, this hole, this hole, this hole. There is also sort of a point here. Let's ignore that. Center rectangle. Switch to a corner rectangle. That corner rectangle is here. That's going to be where the IO is. And we're also going to do this guy to this guy. But yeah, I've never used Blender before, so I'm not really familiar with it. It might be easier. I don't know. But for me, I like this. I can create STLs from this. I can create a whole lot of things from this. I think you can create STLs from Blender too. Can you? I don't know. I am asking. Let's see. We'll go 17 mil. So this is going to be 17 mil between those two. And these are actually 2.5 mil, these holes. They are. So I'm going to click on, because I've defined the diameter of this hole. So I can click on that one, this one, and we can make them equal. So now they're all 2.5 mil diameter. For your information, these screws that hold the IO plate on are M2.5 mil. M2.5 threaded screws. So now we are going to dimension from here to here. And that one, my friends, it's a bit bigger than that, I think. This one actually is there to there. It's looks to be 82 mil. So we've got our triangle, our rectangle defined. This is 82, 82. Now it's defined, but it's not positioned. So we have to determine how far these holes are from the edge of the card. And how far those holes are from the top of the card. So we're gonna, we'll lay this guy flat, and then we'll sort of see. Sorry, ducking out here again. Just measuring off the edge here. We're looking at what? -6. Yeah, roughly 6. Yeah, looking at about 6 mil. I'm using the ruler there, but I'm also going to use the vernier just to
get in there and see as well.
Hmm. Ooh. This thing sit flush with top. Not exactly. Am I gonna have to take this IO to get a proper dimensioning of those? I might. I might. Let's just take it off. Take it all off. Take as many screws out as you need, and then you. All right, might have to undo these screws all of the backplate screws, hey? We'll undo all the backplate screws just so we can get this IO plate off, because I want to get this pattern proper, because I'm going to be potentially mounting with them. I might not. I might just actually sandwich the whole body of the card in. So here we go. Take this back plate off. Come on. I think I got you all. Yeah. There it is. Took the old back plate off. That's why I couldn't take the IO shield off. There's another screw. Now it's off. There. Yeah, so when I'm thinking about mounting it in, I'm thinking about actually mounting it in like so. So with this... Come on, show the people at home. Come on, focus camera. Focus. But yeah, regardless, with the plate off and this sort of mounted right on the edge of the case itself, so it should be somewhat interesting that way. All right, now I can get very accurate dimensions here from the edge, at least, very easily.
So we're looking at what? That extra mil. That was it. That was what it was worth it. That was worth it, huh? $5 mil. It was roughly $6 mil.
Just what I had before, $6 mil. So this guy is $6 mil from this surface. So we've got to make sure we measure from here to here. That's going to be $6 mil. Boom. So we got to define that way, but we haven't defined it this way. So now we've got to define it up and down, which should be relatively easy, considering we've got some flat edge right on the very bottom, which will give us what height here. So we're sitting roughly 4 mil off the bottom here. Yeah, roughly 4 mil off the bottom. Yeah, that's 4 mil. So this bottom portion here is going to be 4 mil. Ah, wonderful. It's sitting right concentric with this radius, which makes sense. Actually, is it concentric with that radius? I could actually probably have positioned it. I don't know what that radius size is actually, though. I estimated that radius size, so we'll just have it like so. All right, those will go in. Now we've got a cutout there, which is precisely 22.4 by 76.26. 76.2, well, probably 76.25, because usually they'll have, all right, so we're going to go in here. We're going to go boop. We're going to draw another rectangle within this rectangle, and it's 76.25. 76.25 high. And this actually, we're going to take this and we're going to make it centered, because I believe this hole is centered. And we are going to dimension the width of this, which was, what was it again? Because this is going to be important, because if I want this attached directly to the side of the case, this is going to be 22.46. So 22.46 is, oh, we're going to assume 22.5. 22.5. All right, so that is wider, right? And we've got then right next to it the thickness between our IO, and that is, let me see, here we go. HDMI, or the saving one, is 2.3 mil. 2.3 mil. And then there's our IO, which then goes 2.3, then it's 86.82. 2.3, then 86.82. So this here is 86.82 high. 86.82 high. And then this, let's see, get off that. We'll go here. Smart dimension. This to here is 2.62, I believe. Let me just measure that again. See if it's right. 2.35. Yeah, 2.3. 2.3. Or are you supposed to be 2.5? No, you're 2.3. 2.3 mil. That's 2.3 mil, and then this goes all the way to there. But this here, I believe, is, oh, there's a little gap at the bottom, which tells me how far off the very bottom it goes, and that is 1.25 mil. So this sits 1.25 mil off of here. Smart dimension, 1.25 mil off of here. And this is right on that. So that would be collinear. So collinear says, you know, that this line is right on top of that line. So they are collinear. Boom. So that is our IO port. This is our vent, and these are our holes. So we are going to extrude cut this one, this guy, this guy, this guy, because this is just actually the structure for, not structure, this is just sort of what we use to define where these holes are. Along with these holes, we're going to go, and then we'll go here and here, here and here. We're just selecting regions that are going to be in this, and we are going to go through, we can go blind, I believe. Oh no, we can't go blind with that. We can go, okay, this is going to be different. We are going to need to do, I think, a couple of different ones. Yeah, because we can't do multiple, so we're not going to do this one this time. Nor are we going to do this one, or this one. We are going to do just the holes for now. And those holes are going to be just sort of, yeah, I'm going to do like 5 mil. Why not? Because those can go through if I want up there. It doesn't really matter one way or another. So we're going to cut those holes. So now we got those holes, but we have that sketch, right? We want to do another cut. So actually what we can do is we can click on that sketch, and then we can do another extrude cut, and we're automatically going to use that sketch all over again. And now we can select this guy, and this guy, as well as this guy. And I believe believe we can just run those blind. Yep. And we'll go boom, boom, boom. Oof. How far does that one go? Not super far, actually. It actually goes roughly to the next, right up to the first screw, which is about 16 mil. So you know what we're gonna do? We're gonna do that 15 mil right there. Boom. Done skis. Boop. So we've got our cutout there for our IO. We've got our cutaway here for our vent to vent these holes and stuff out. So I am going to reattach. Maybe I'll reattach after the stream just so we're not like putzing around with things that are not necessary. But here you can see we've got our metal frame pretty much done. Those are all the features really. Ah, no, there are a couple of mounting screws there. So actually, I am going to put this back on because I do want to move it around, but this thing is actually quite, it's actually quite loose and wobbly. Let's see, are these all the same? Yeah, these are all the same. Shame screws. Shame. Except for what? No, those are the same. Just checking if one of these is different. Oh, yes, there is one that is different. It's this guy. This guy. Just gonna quickly reattach this IO plate. Must say, I do like how these cards are just, they're kind of a joy to take apart in a way. Maybe not a joy, but they're not terrible. Let's just put it that way. They're not terrible. Yeah, I'm gonna actually screw this plate on here. I should properly attach these and then fasten the other one down. So I'll actually take that off. Fasten these IO plate biddies on again. But yeah, it'll be kind of interesting to sort of attach this onto the actual onto the actual case itself rather than like in your standard PCIe configuration. So that's sort of one of the plans I have to just get a better idea, not a better idea, but like get a better footprint on this guy by doing that. And also I'll have a better flow of the better flow of the air coming out of the case without the the IO plate there. So the IO plate does have minimal restrictions, but there are some restrictions. So just gotta get this thread to align. We'll wait on that one. We'll do that one later. There we go. They all have like thread locker on them, which has been broken because I've taken this plate off a couple of times already. Not broken, just I've cracked the thread locker loose, so it's not really thread locking anymore. But it attaches nicely, so why not? Why not? I know, I wish I had like another camera for showing the taking these things apart and putting them back together, because it's like kind of, I'm just doing dead stuff off the screen right now. But we're gonna do a few more bits and then I'm gonna try and do that heatsink. Yeah, because right now on the back of this there is these two right here, and I might want to use those two as well. These should be a little bit easier, as they are. Let's see, they're spaced, what, roughly 17 mil apart? Yeah, 17 mil apart. And we're looking at like 17 mil apart and about 5 mil off the back plane. So 17 mil and 5. So we're looking at here. We're going to do cut. So we've got 2 holes here, 1 and 2. I'm going to think these are pretty small. I'm going to say they're 2 mil. Right? Yeah, 2 mil. Little baby holes. Here to here is going to, we're going to make sure that these are horizontal. So relations, these are going to be horizontal, not horizontal. So it's always good to go normal to your sketch plane. These are actually vertical. There we go. This and this is equal. This right here is going to be 5 mil off of there. So both of them are going to move because we already created that relation. These are 17 mil apart, I believe. 17 mil? Those little extra support biddies there. Maybe 17 and a quarter. Let's say 17 and a quarter. 17.25. And then the tricky one is how far off of the ground are they? Off of the ground. Gotta love that terminology. Off of the ground. Let's see.
This one here is 16, 17.
Yeah, we're looking at like 19, I think, here. 19 or 18 and a half. Yeah, we're looking at 19. 19 mil. So this guy here is going to be from here to here, 19 mil. Yep, that's about right. Now we're going to cut that, and yeah, it's going to go through those. Perfect. Beautiful. There's those little mounting holes. And so there we go. And we are going to have our back plate, which is roughly going to have our PCB in it as well. And that is overall going to be about 4.5 mil. 4.25 mil. 4.25 mil there. Yeah, 4.25 mil. 4.25 mil. So go here. We're going to do an extrude, boss/base, and guess what? We are going to do, yeah, we're going to convert this right here. And we're going to do, yeah, you know what we're going to do? We're going to do a little mirror action here. We're going to take this line right here. And we're going to bring it to here. And we are going to also bring this line. We're going to convert that as well. We're going to bring this line over here to here, just because we want this fully extruded back, right? And because this is a gap there, we're going to have to connect this here too. And you're going to see, because we want to fully encase our, because we're going to extrude a whole block coming back 4.25 mil. So we're going to do that, and we're going to do a little, oh, okay, we do have that fully encased now. Yeah. So extrude boss slash base. We're going to go there. We're going to go there. Going to go there and there. And this is going to go back 4.25 mil. And that is basically going to be our back plate. And what I can do is if I want it to look like a back plate, I can go here and I can change the color on it. That feature, you know, I want just that feature. Yeah, so just that, not the whole thing, just the feature. Can I change that to just, no, I don't want the whole thing to be black. Appearances. Boss extrude there. I should have just clicked on that. And now I can make that feature black. So there. So this has been extruded back, and we've got our back plate, which is black. Kind of cool, huh? And so now I'm going to do... All right, so I'm going to put some fans in. And they're going to be just a rough fan. I'm not doing fan blades. I don't have time to do fan blades. Let's just put it that way. Fan blades are not going to be necessary in this. All right. And additionally too, actually, you know what? First of all, more importantly, rather, is we're going to need the PCIe slot here. So the PCIe is going to be, second here, I'm just going to quickly set something up here. Okay. So yeah, PCIe from the front of the card to the PCIe is 45 mil, and I believe that is a spec straight out of Compton. No, gonna do here. So extrude boss slash base, and we are going to do a rectangle. And we are going to actually go normal to it quickly. So we go normal. And we are going to use this as our point for one side at least. And this is going to be roughly where our PCIe is. Actually, we're going to actually get rid of that. That's not going to be coincident on that. But this is going to be coincident on that side because that's where the PCIe slot is. So we're going to make that collinear. So that's defined there, but we're going to dimension that to there is 45 mil. So that's 45. Boop. And we've got the length of our slot is coming off at the length of the slot is about 94.5 mil. But overall, for that total, actually, no, I'm going to do the total slot. I'm not going to do like the gaps and stuff. Yeah, you're about 100.5. No, 100 mil. 100 mil is the thickness of that, and the thickness of the PCB is 1.65. Length is 100. So this is 100. And the thickness is 1.65. 1.65. Okay. So that is our PCIe slot. So we will extrude that. And the height that it comes out is how much? How much is 13.28? 13 mil. 13 mils. So that is 13 mil. Boop. So there. And we're just going to do a block coming out. I'm not going to do the individual fingers and all that. I'm just using this for how big this card is. And we're going to do some stuff for fun. Why not? Okay? Can do a little bit for fun here. Baby has woken up, so I've got the baby on the monitor here, and I'm observing. And in a few minutes, if baby is not asleep, as we are sleep training right now, I will be leaving the stream to take care of baby. Let's see here. I'm gonna try doing a pattern here. So here we've got. No, I'm going to do a reference geometry. So we're going to insert some reference geometry. So right now, if I want to do a sketch, I have to either click on a face or on a plane. And there's no face because I want to actually do a fans, or at least just a cylinder to show where the fan is. And the fans are roughly flush with these edges of the chamfer. And the only problem is that you can't select the edge and create a sketch. So what I'm going to do is I'm going to insert some reference geometry. So here you can insert, and here you've got your basic, features here, but you can also insert reference geometry. So I'm going to create a plane. And so the first reference is going to be here. The second reference is going to be here. So now we've got a plane that's level with the edges of the chamfer. It says here fully defined. Boom. We've got a plane. Selecting the plane, now we can do extrude boss / base. So we will do, now I'm going to do very basic. So we've got our circle here, a circle here. These are our two fans. They are equal in size. And I do believe, yes, they are also in line with each other. So they'll be horizontal. Dimensionally, they are, let's see. Dimensionally, you fans are how big, huh? About outer dimension is about 86 mil. So 86 mil, 86. That's where they are. And I am going to make an assumption that these fans are centered in here. So I'm going to select this midpoint. So I can select an edge. You don't have to even convert the edge. You can select the edge because we have an even radius here and here. The center of this is actually, oh no, the center of this is actually in line with this. So I can select the origin. So we're going to go back to normal just so we can be sure that we're selecting the origin and not some other random point. So there's the origin, and I'm going to select that, and I'm going to select that, and we're going to say horizontal. So they are all in a line there. Those are correct. So now we're going to roughly figure out how far from the center to the outer edge here. 56 mil from this one. So it's really nice because there's like concentric circles on the hub of the fan, which basically tells me exactly where dead center on the fan is. So that's handy. So I can actually even measure, I think, center to center on them quite easily. $128. $128. So we're going to go 128 here to here. 128. Boop. So that's where our fans are. And we're going to, I don't know. I'm just going to extrude them as a solid block. I could do some fancy profiles and stuff, but I just really don't have time. It's 12:30. I should be going to bed. And also doesn't look like the little one is quieting down too much. Maybe they're falling asleep. We shall see. But we're going to extrude these. We'll do both. And we'll reverse that. And I'm just going to go straight to here. I know the fans don't go all the way down. But again, like I said, I'm not trying to make this a perfect thing. We're going to go up to surface. So these are going to go up to that surface. So boom. There's our fans. And you know what? We can even change the look of our fans to be as well black. interesting thing is here you can actually do appearances, and you can actually add like preloaded like chrome finish, satin finish, brass, copper, iron, titanium, all these things, rubber, different types of rubber, painted, car type fabric, even uh, organic. You can make them. I can make them look like they're wood. I can make them pine, the pine fans. But no, we're just gonna go black uh, on them, and there's our fans. Now, I really want, actually, what I really need to do is still track where our IO is, right? So we do want to know where our IO, not IO, our power connector, because that is going to be a critical part to this. So our power connector is, in fact, 110, and our power connector is, so it's 110 from that side, and it's this big, 18.75. And it's about 7 mil thick. So I'm going to go here. I'm going to do an extruded boss slash base, and we are going to convert that, and I'm going to do a corner rectangle here. Oh, there. All right, we're going to go smart dimension this here to here is about 110. I believe that's what I said, 110. No, 105. 105 mil. 105. And then this here to here is 7-ish. And then this to here to here. Oh. Okay. We're going to be wrapping up real soon here. 18.75. I'll say 18.75. Whoop. So there's our power connector right there. And we are going to features extrude boss slash base. We're going to select this, and that is actually going to go down because it is flush with the top of that. So we're going to go blind, reverse, and it's just going to go down like that. Boop. So there is our power connector. And I'm going to make the power connector also black. Or we're going to go dark. Right. So there we have our power connector, our fans, because I need to know where the fans are too if I want to make sure that there's holes in the case to allow for inlets. And that is, I'm going to hide that. So there we go. We've got our PCIe slot, our outer frame for our outer sort of dimensions on it. This guy here, I might do a cutaway for the pass-through that is there. But yeah. So that is that right there. So that is where we're going to leave it tonight. It was going to be a quick little stream. Oh, this document has not been saved in the last 20 minutes. Save, save, save. So we've got our 3060 Ti right here. I've removed that. I don't have that plate because I want to take it away, and I actually kind of want to nestle this in the panel itself. So I might have like a depression in the panel on either side because I can get rid of, because my panels are rough. The panels I think I have roughly are like they're 4 millimeters thick. So if I can nestle this in 3 millimeters on either side, I can shorten the case by 6 millimeters, which doesn't sound like a lot, but I'm trying to get it to 7 liters. So 7 millimeters is a big deal. So that is going to be it though for tonight. I want to say thank you everybody for tuning in. Be sure to leave a little like, and I hope you learned something. There's a lot of other functionality. I was going to do a pattern for the fins in the heatsink, but time did not allow for that. But this is roughly what I need anyways for putting it into the case. Uh, Once I have the case fully refined and laid out, I might do another stream just showing what I've got so far. But I think it's going to be pretty impressive that I can do a 7 liter case with full height graphics card that's not even an ITX length graphics card, with SFX power supply and it's going to be just sort of a stock Intel CPU cooler, but I might even at some point throw in the idea of potentially a water cooled build. But either way, um, thank you again for stopping by, for sticking through. I had a bit of a technical difficulty early on, so appreciate everybody for sticking around. And yeah, if you liked it, hit like. If you want to see more, be sure to subscribe. I'm going to be describing a little bit more of the build and that later on. Um, and yeah, have a great night, guys, and I will see you in the next one. Bye.